All right, I think we'll get started. It is 10 past 3 per my phone. We'll get started. I think phone is the real truth of the time here. Good afternoon, everybody. My name is Arun Gupta. I work for Red Hat. Originally, I was supposed to give this talk with Alexander Husingfield, but he couldn't be here because of some family reasons. Nothing sad, but he's just having a fun time with his family. A lot of events happening in his family this week, so he's having a great time there. And I'm here, having a fun time with you guys, giving a talk on concurrency in enterprise Java. How exciting. All right, I work for Red Hat. I run their technical marketing and developer advocacy team. Prior to that, in my life, I spent 14 years at Sun Oracle, where I was responsible for driving Java EE evangelism. So I have a lot of experience with Java EE in that sense. So let's jump right into it. Typically, when we write a thread, in a Java programming language, this is a very canonical hello world how we get started. You just have a runnable interface. Runnable interface has a run method. Where you put your logic in that run. You say new thread, you pass it in the interface, and it just runs it in a separate thread. We're not talking about any details here at all. But that's a very classical thing, that works very well in a Java SE style of application. But these threads, you can create them in Java EE. Java EE platform does not allow you to create threads, and application server prohibits them. Well, the reason is because Java EE is a managed environment. That means there's a container, or Java EE container, which manages everything for you, the life cycle of components, applications, threads, context, everything for you, which is not possible if you're doing, or if you start creating your own threads. So essentially, there is no management of thread lifecycle or the number of threads. How do you configure the number of threads? How do you monitor across those multiple threads? And the most important problem being, when you're running a Java EE application, is running in a particular context, security context, class loading context, and so on. How do you pass that context to the thread? There is no standard mechanism to do that. You have to hack your way around it. So for all those reasons, it's not recommended to spin up your new threads in Java EE. Then there are also certain patterns of software stability. This is an excellent book by Michael Nygaard on Release It. And some of the patterns that he talks about of software stability are, how do you how do you make sure that a thread is not stuck waiting for a resource forever? So define a timeout on that thread. That's very important. So that's a very important configuration aspect of a thread. Bulkheads, these are a standard concept in shipping containers. I'm sure you guys remember the movie Titanic. We saw in that, and some of you might have read the book also. It talks about how there were bulkheads in the shipping container in that ship itself, so that if one container loads up with water, it's not going to impact the rest of the ship. So similarly, there are bulkhead design pattern that you can implement in your application. Say if one thread is growing rogue, it should not impact your other threads in the application itself. Circuit breaker, again, a very important concept, very relevant to threads itself, where it says if there are no threads available, if you want to access a resource and that resource is not available, or a thread is not available to serve that resource, you should fail fast and then recover and ask it to try again, basically. And then there is a steady state as well, another important design pattern which says, I want to start up my application. I'm going to have a steady state. That means these 4 threads are going to be created. That's going to stay in the pool. I can increase, but I will never go below 4. These are unused resources, but I'm okay to have those 4 or whatever that number is as a steady state of my application. So the focus of the presentation today is going to be looking at what Java EE7 provides you in terms of JSR 236. So I'll give you a full view of that. If Alexander was here, he would have talked a little bit more about Guava and JDK 8 streams and other concepts as well. But the focus of the presentation today is going to be all about JSR 236. Well, JSR 236, the name itself is Concurrency Utilities for Java EE. Now, the number kind of indicates that the JSR was started a few years ago, then it got in a limbo state, and finally Oracle moved along and then had that JSR implemented now as part of Java EE7. But basically it gives you a simple and a standard API for doing concurrency in your Java EE applications. It leverages all of your Java SE extension mechanisms or Java SE concurrency utilities. So if you recall Java util concurrent package, now which is JSR 166Y, it leverages all of those design patterns and bring them to Java EE. Effectively, what you get is, as I said, in Java EE, you cannot spin up your new threads. It's kind of lied in the beginning, but with Java EE7, you can do that. You can create new threads, but these threads are now done in a very safe, reliable, and consistent manner. And consistent in the sense that it's consistent with what the underlying application server or a runtime is expected you to do out of it. There are also capabilities on how you can manage these tasks, monitor these tasks, get event notifications when the tasks are completed, and so on and so forth. Now, remember, these are very, very low-level APIs, so the expectation is really you'll build frameworks on top of these and then be able to leverage them. So what does this JSR 236 give you? As I said, the name is Concurrency Utilities for Java EE. It effectively gives you 4 managed objects. Just like we have Java util concurrent, this is Java X Enterprise concurrent. That's the package we are looking at it. And all the packages pretty much, at least the 3 objects derive exactly from the Java util concurrent, namely being manage executor service, manage schedule executor service, and manage thread factory. These are essentially managed version of the objects that already exist in the Java SE land. And then the new concept of context service is being introduced, which is again very similar to a concept in Java SE, which we'll talk about. So what are these managed objects? Just that's in a very classical Java EE sense, these managed objects are essentially provided by the Java EE product provider. So Wildfly is a Java EE7 compliant application server. You want to access these managed objects, you can say, I want an object, and the container will give you an object. You can also have application managed objects where you say, oh, you know what? The objects that are given by the container are default, but I want to create an object that is specific to my application. So then you have the capability as well. Well, with that, you can do a JNDI lookup, or you can inject them using resource, independent of whether they are application managed or product managed. The objects are configurable. Now, the configuration is a little bit of a tricky part because that configuration is not specified, or the specification for the configuration is not defined in the spec. The spec of the JSR 236 spec, all it says is there should be a capability to inject this managed objects. It does not say how you should configure those objects. So that's a missing hole as part of JSR 236. Hopefully will be addressed as part of Java EE 8. The cool thing is, if you are starting with the Java EE application, you have the ability, there are 4 default managed objects that are available to you. And what that means is, out of the box, if you're using Wildfly or Glassfish or any other Java EE7 compliant server, you can say, inject a managed executor for me, and it'll do that for you. What that means is, you don't have to create these objects to begin with as part of your application development process. So for example, typically, if you're building a Java EE application, you will give it to an application server and say, oh, by the way, create this JDBC resource, create this JMS resource. Now, this would have added another thing over there. Now, here is saying, oh, if you're running a Java EE7 server, there are default objects available for you. Use them, get a feel for it, and then later on, you can create your application-specific objects. And we'll take a look at that. Now, we talked about context a little bit, that one of the problems, or rather the biggest problem with creating your own user threads is how you cannot pass context, because the Java EE components are running in a particular context, which is the 3 contexts being class loader, security, and JNDI context. What that means is, if the multiple contexts are running in the same security context, so if you say get user principal, it's going to give you the exact same principal or the context that you're running in. So, you can do multiple operations in that same context with the same security context. So those 3 contexts are propagated from the thread or from the object where the thread is created. So let's say there is a servlet in which you inject a managed executor service, and you spin up a thread from there using that executor object. all the contexts that are available for servlet are then automatically propagated to the managed executor service. When and how these contexts are propagated, we'll talk about that. Now, the transaction management is not propagated because that was a conscious decision taken by the expert group that coordinating transaction across multiple threads is a big, hairy problem. So they said it's not going to happen. However, there are mechanisms by which you can actually run user transactions within the thread itself. Now, these threads are running. One of the things that is very important in terms of monitoring these threads is, tell me when the thread has started or stopped, because now the container is running these threads, or when you're submitting a task, when the task has submitted, aborted, canceled, so on and so forth. So there is a task event notification mechanism as well. All right, so let's take a look at our manage objects one by one. Well, the first one being manage thread factory. Now, this is very similar to how we do that in the Java SE land. It's a very standard way to obtain a container managed thread. Okay, and the way we do that is, well, first of all, it supports context propagation. So each of the managed objects, I'll talk about what they support and what they don't support. So it does support context propagation. All three, JNDI, class loading, and security contexts are propagated. They can be used with the asynchronous servlets, and we'll show an example of that. And so the typical example is, you have a managed thread factory, you create, you inject it somewhere, and then these managed thread factories can then be used to create custom executors and advanced use cases. So let me show you those use cases for you. Well, first of all, it extends from java.util.concurrent thread factory. So what that means is, all the functions that are there in thread factory in the Java SE are available to you in this Java concurrent or Java enterprise concurrent package to you. What that means is, all of your Java SE design patterns are very well applicable in the Java EE land as well. The difference being, they're now run in a managed environment. So very same API, once you have injected your managed thread factory, from the thread factory, you say thread dot, from the factory, you create a new thread, you pass it a runnable interface. So very, very similar. There's no new learning that needs to be done. The important part to understand is, when is the context captured? Well, the context is captured at the time of the managed thread factory creation. So for example, you are injecting a managed thread factory, depending upon at what point the thread factory is injected, your context is captured accordingly. Or if you are doing a Jindy lookup, let's say you are doing an application managed lookup of the managed thread factory, let's say it's done within a method. Now that method may be called in a particular security context. So then that security context is captured. So the point being, all the context, JNDI, class loading, security, are captured at the time of the creation of thread factory, not at the creation of the thread itself. All the threads that are returned, they implement manageable thread interface, and effectively it gives you just one method, or one additional method, which is basically saying is shut down. Because now remember, this thread is automatically spawned for you by the container, so you need to have the capability to figure out whether the thread is shut down or the thread is still running. And this is very useful in your application if you want to react upon a particular thread. Now, any thread that is created with managed thread factory can be used with your standard Java SE application. So you can say java.util.concurrent executors. Let's say you are having, you're creating an executor using this particular executor's utility class, and then you create a thread where you pass a thread factory. It will be actually a Java EE managed thread in that sense. Now, the thread itself would throw, or when the managed thread factory, when the thread is interrupted, when managed thread factory shuts down. So you get a notification that, okay, now the thread is shut down. Remember, because this is all done by the container, there are multiple threads running in the background. Somebody else might interrupt it, or the thread factory might shut down. Let's say your application server crashes for some reason, then your thread will get interrupted, and then you will need to act upon it accordingly. So let's see, how do we do this? Well, here, I'm going to inject it. I'm going to just say manage thread factory. This is a very standard Java EE programming model. I'm using @resource, but you should be able to use @inject, which is the recommended design pattern. So you say @inject manage thread factory. And in the manage, you can just have a convenience method, say manage thread pool. Here you're creating a thread pool executor where you're actually passing the factory. So remember, this thread pool executor is a very standard Java SE class over here. So all I'm passing is a thread factory that is a managed thread factory. How would you use this in an asynchronous servlet? So then you take a look at public class test servlet. Now this is an asynchronous servlet. The fact that we have async supported equals true here. Once again, I'm injecting a managed thread factory here. In a do-get method of async servlet, all I do is literally as soon as I get into the method, I start the request asynchronously. And then eventually at some point of time, I'm going to say, okay, I'm going to spin up a new thread and in the thread have basically a runnable interface, and in the runnable I have a run method. But you can't create a brand new thread here. But here, what I'm doing is I'm using the managed thread factory to create a thread. So this is a perfectly legal code, as opposed to just creating a thread factory here, which you can't inject anyway. So you will have to create a thread factory, which would be illegal code in the Java EE language. But because the fact that you're using a managed thread factory and injecting it, this is still a managed code and can be managed by the app server or the container. And then, of course, you do your usual thread.start over here. The second one that I'm going to talk about is manage executor service. Now, this is again very similar to the executor service that already exists in the Java SE land. So this is for running tasks asynchronously on threads provided by the Java EE container. Here, the tasks can implement runnable or callable. There are subtle differences between the two, which and when you will use the two. But either of the interfaces are supported, and I'll show you examples of that. The managed executor service also provides support for context propagation. So once again, your class loading, JNDI, security, all those contexts are automatically propagated from where the managed executor service is injected to the actual thread. And because it inherits from the executor service, so all your standard Java SE design patterns are very much applicable here as well. So here you go. Now it extends from java.util.concurrent executor service. So all of your standard Java SE design patterns are available. So methods like execute, submit, invoke all, or invoke any. Now there are subtle differences between each of these. So for example, in invoke all, you can give it a collection of threads and it will invoke all the threads. In invoke any, you can give it a collection of threads, say invoke any of the thread, and one of the threads will be automatically invoked. Now these are again very standard Java SE design pattern, but now they're available to you in the Java EE land or the enterprise Java land. So really there are no new APIs. It's just a new interface which basically gives you the ability to be injected in a Java EE environment. Each of these methods, they return a future, which is again a standard JDK concurrency API, which was introduced in JDK 1.6. That future can then be used to check for the task execution status. Oh, has the task completed, or is the task still in progress, or you can even cancel the task, for example. And once the task is completed, then there are standard APIs to retrieve the result. So the key part that I want to highlight once again is very standard Java SE design pattern principles available in the Java EE land here. Now, because this is managed by the container, so all your lifecycle APIs are disabled. So for example, is terminated, is shut down now. Those methods are disabled because as an application developer, you don't have control on those methods. Let the container decide the right thing for you in that case. So let's take a look at an example here. The first example we saw was using runnable. Now I'm going to use callable in this case. I'm just injecting a managed executor service. And remember, I said each of these managed objects have a default provided by the Java EE7 container. So the fact that I'm saying add resource managed executor service, if I take this example, run it on any Java EE7 compliant container, it should just work out of the box because there are default objects that have to be available as part of it. But effectively, in a some method, I have a callable where instead of run, I'm implementing call here. I have, this is where I'm doing my complex calculation and returning the result. And in case of, as I was saying, between run and callable, there are subtle differences. One being, if you're using runnable, then there is no return type. In case of callable, there is a return type, for example. So here, now I have my managed executor service. To the executor, I submit the callable object. and this is going to give me a future object. Now, ideally, it should give me a future of integer, so I can poll it constantly. Here, I'm just simply saying result, give me the result without waiting. But ideally, you will say, is the result ready? Because your use case would be typically you will spin up this thread if it's running, a long pending operation. So one of the use cases, for example, I've seen, one of our customers was using, they were required to use SendMail API, whole bunch. Okay, kind of lost for a moment. So one of our customers was using SendMail API to send thousands of emails at the end of the day. So instead of running it in process, they spin up a new thread because SendMail was using a few seconds to send those emails, and when those emails were done, then they will actually retrieve the result. Oh, emails are done or emails are not sent, whatever the result is, and then they will constantly wait using the future object to check the status in that case. So that's a very typical use case that we have seen how people are using managed executor service in a production deployment. Once again, in the asynchronous servlet, for example, what you could do is you can inject your managed executor service. I'm using Runnable in this case. In this case, as soon as you get into the do-get method, you are starting up an asynchronous context, and in the run method, you do your business logic, whatever needs to be done, and effectively here is at the end of the method you say async context.complete. That means my asynchronous request for the servlet is really now complete, and then it returns the results. And at the end of the method, of course, you say executor.submit. Now, one other thing you may realize is there are, and maybe I'm jumping ahead, but there are a lot of different asynchronous APIs in the Java EE land. There is a EJB asynchrony, there's a servlet asynchrony, then there is this JSR 236, then there is JAX-RS asynchrony. So hopefully as part of Java EE 8, and they have their own programming models, it kind of becomes very confusing sometimes. So hopefully as part of Java EE 8, all of those would be lined up and cleaned up. They're saying, if you're using servlet, this is the API you should be using. If you're using EJB asynchrony or other, have one unified asynchrony programming model across Java EE 8. So if I give you a little bit better idea on how the whole thing looks like, this is a beautiful diagram, I think, captured right from the spec itself. So on the left, first of all, this is where my app server container is. I have created a managed executor service, let's say, and then I have a thread pool. In the thread pool, I talked about steady state. Okay, so this could be my min, basically saying 2 is my steady state. So at any given point of time, I will always have at least 2 threads available to serve the request. Now, the gray box is really what is indicating, or an empty gray box is what is indicating that how this is my empty or my thread that is available. Here, I have 3 apps showing in different colors, and the color really, they have their own context because they're all running in their JNDI context or class loading context or security context. Now, these could be 3 Java EE components running in the same WAR file, but they could be, depending upon how their contexts are configured, could be in a completely different context. So, if the same managed executor service is being used, then a thread is being used from that managed executor service, they actually pass their context to the thread, and when the thread is running in that context. So gray is the empty thread, with a thread that is available for you to serve the request, but when it's running, in a particular context, it is actually colored in that context. And here I'm saying, so 2 is the minimum. So let's say there are no requests that are available, then 2 threads would always be available. Then I have a max state that I'm defining that, okay, I can have a maximum of, say in this case, 10 threads, and then there is a queue available. Well, ideally in this case, queue should be empty because there are still 3 threads available. So those 2 threads should be available as part of the max itself. Okay, so that kind of gives you an idea of how managed executor service and multiple components can really work with each other. So that's kind of cool. The theoretical concepts are good, only so much good, but how do I actually try this out? So here you go. So this is, in Wildfly, we have this command line interface, which allows you to create these executor service. As I said, there is already a default managed executor service or a managed thread factory that is available to you. So you don't have to do this, But if you want to create an application-specific manage executor service, that can be done too. Now, the command line may sound verbose, but that's not going to be your everyday thing anyway. But the Wildfly structure is a managed tree of different domains and different modules. So in this case, I'm saying I'm looking at the EE subsystem, then I'm looking at manage executor service. I'm creating my manage executor service over here, and I'm using an XPath notation. So I'm adding this node here to the managed tree of the Wildfly administration, and then I'm specifying values here. And the values are, I want 5 core threads, which is my steady state or minimum state. Then I'm giving it a GIND name. Then I'm talking about TTL. Then I'm talking about reject policy, maximum number of threads, and so on. So that's how you really add a new resource. This is then becomes an application managed manage executor service as opposed to a default manage executor service. And removing this node is as simple as calling this command. Now, this is typically done in a shell file. So you can say JBoss Cli.sh-c. C means connect to the server and give this command, and you give the command. And you can replace the command within the quotes with this, and it'll remove that node. Now, this is daunting. For the first-time user, this is really confusing. So, well, we have a Wildfly CLI command builder. So what you do is you fire up JBoss Cli, you say -- GUI, and it brings up this nice command builder, which shows you the entire Wildfly management tree on the left-hand side, as you see over here. So it shows you all the different subsystems. And in this case, I'm particularly pointing at manage executor service. So you say subsystem EE and so on and so forth. You literally right-click on this, and you say add a new node over here. As a first-timer, if you're starting with Wildfly, you fire up Wildfly. You just say bin standalone.sh. Once you fire it up, then you say, oh, you know what? I'm going to fire up the GUI management tool or the command builder. Then you look at the tree, then you right-click on this, then you add the executor, and right here in the CMD window, it's going to show you the exact command. So you can fire the command from the command builder itself, and then subsequent usage, you can actually copy the command in a shell script if you want to for your DevOps purpose. You know what? I want replicated environments. So typically what I do is I create a Docker file, and in the Docker file, I add up all my resources that needs to be created, and then I have a very custom-ready Docker image that I can use whenever I want to. So I literally say run Wildfly, and all my managed executor services, my JDBC resources, my JMS resources are automatically created for me as soon as I fire that image. All right, so let's talk about manage schedule executor service. Once again, this is a very standard Java SE class, but it's used for scheduling tasks to run. And there are different design patterns here. So for example, you may want to run a task after a given delay. That I want to start the task after a certain delay and let the thread be run every 5 seconds or 10 seconds for some reason, periodically. So that's the option over here, and at a completely custom schedule. So all these options are available. Now the tasks are run on threads provided by the Java EE container, which is a big difference over here. And so even though you're running in all these different algorithms, but all those contexts are available to you. So they do support context propagation, and we're using all the standard Java SE design patterns. Okay, so let's take a look at the code. Well, the fact that it is extending from manage executor service or java.util.concurrent manage executor service. So all the JSR 166 methods are available to you over here, which are schedule at fixed rate, and schedule with fixed delay. So those are, there are other methods as well, but those are the 3 that you would most commonly end up using. And there is even extension API to support custom scheduling. We're not going to cover that today. Well, I think we will cover that today, I guess. Schedule with trigger. Just like other services, or your other managed objects, your lifecycle APIs are disabled because the reason being the lifecycle is now managed by the container. So the container will call these methods as appropriate. So let's take a look at the API from Schedule Executor Service. And remember, I say Schedule Executor Service. I'm not saying Manage Schedule Executor Service because they're exactly coming from that class itself, but you're using them in the Java EE context. So the first one here is schedule. So all you're saying is schedule this task here, pass it a runnable. There's a callable version as well. Yeah, there's a callable version as well. You're saying after this much delay, and what is the time unit? That means seconds or minutes or days, whatever it is. So you're just scheduling a task after a certain seconds. That's one simple usage over here. In this case, you're saying what is the initial delay? That means schedule this task after this many seconds, and you want to schedule it every so often. That okay, schedule this task every. First time schedule the task after 15 seconds, and then after schedule it every 5 seconds. So the initial delay is 15, and the long period is really 5. So that's how you're going to make the call. And there is nothing new in these APIs. These APIs have existed since JDK 1.6. This is just a runnable and a callable. Well, no, this is schedule fixed rate and schedule with fixed delay. The slight difference between these two calls is, in one case, let's say in both the cases you have said initial delay is 15, and after that 5 seconds every time. In one case is gonna schedule the task every 5 seconds, and eventually you may run out of threads if your tasks are taking longer than 5 seconds. In the other case is gonna wait till that first task is finished, and it will not schedule a task until that task is over. So depending upon what your use case is, you can use either of the methods. So this is the one for the custom scheduling, for example. In this case, you have both callable and the runnable aspects. And trigger is a method, or trigger is a class that you can use for custom scheduling. So let's take a look at trigger. This is used for custom scheduling rules. There are different formats that you can adopt for trigger, and you can say single absolute date time, either of those formats. Or you can have complex calendar logic, so like cron tabs and things like that can be very easily configured. And the triggers can be related. There do this trigger, then do this trigger, and that can be specified. And these all have to be implemented in your code. There is, I think, some of the key missing pieces, in my opinion, from the JSR, this particular JSR, is how all of this has to be done in the code. There is no configuration aspect of it, wherein I can say, just configure this as part of a configuration file. Typically, how you would do that for EJBs or using, if let's say Quartz API, if you can very easily do that using configuration files. There is a schedule method, and so you will just call the schedule method, pass your runnable or callable, and the implementation of the trigger class. In the trigger class, there are a couple of methods that are important. So you would say skip run or get next run time. So you will implement those methods, and you will actually pass some information like last execution and the date, which basically tells you when was the last execution, or whether it was successful or not successful, was done, and the date when it was executed. So based upon that, you can actually implement those methods and then make a decision whether the next should be done or not done. So in this case, for example, you could pass a Boolean. That means you're going to skip the run. Now, I just saw that the last successful run was unsuccessful, so skip the next run. So it'll just keep coming back at this method. Or in this case, you could say, oh, the last execution was successful, and I want the next execution to happen at such and such date. So you return that particular date in that case. So here is a slightly simpler, slightly more verbose implementation, so to say, for simple fixed date trigger. I'm having a fire time. I'm creating a simple fixed date trigger here. All I'm saying is get next runtime, and I'm saying if it is after the fire time, then you return null. But if it's not, then return fire time. So that means fire it at a particular date time. And here I'm just returning skip run based upon whether it's before or after the fire time. So this is a roundabout way of implementing a job at a particular date time, but you get the idea that how these methods could be really complex and be able to achieve those complex calendar logic as part of your algorithms. The last but not the least object as part of JSR 236 is context proxy. Now, the first three objects that I talked about so far, they're all focused on the side of, hey, these are standard Java SE design patterns, we're within Java EE land, all they would work. Now, context proxy is something new that is introduced here. Basically, it allows you to create contextual proxies. What are those? Well, at given point of time, you can capture the context, And then you might be running in a slightly different context altogether, or completely different context altogether. But when you want to invoke the object, then you want to run in the context where the thread was really created. So let's try to understand. In this case, the application context is captured upon the creation of the proxy. And then those proxy methods are used later to run in that same context that was captured earlier. Okay? So it's typically meant for advanced use cases. So we expect that in most of the common use cases, your manage thread factory, manage executor service, and manage schedule executor service would be sufficient. But if you want like slightly more advanced use cases where a context is captured at one place and used at some other place, and I'll show you a sample for that, then you can use contextual proxy. So for example, you want to propagate user identity. The security context is captured at one place, and then when you're running it at elsewhere, you just want to propagate the user identity because the context is already captured here. When you run it at a later place, it'll run in that same context. It does rely upon Java Lang reflect package and the dynamic proxy mechanism to have that functionality available. There are certain execution properties that are available in contextual proxy, which basically defines what can be done. There is a transaction property, and I'll show you the values for those. And there are certain vendor-specific properties that are available as well. There are, of course, API for returning properties on a given contextual property instances, based upon which you can actually make a decision. So I think, as I was saying, I've been saying all along, I think JSR 236 is where some of the loose ends are available, which allows more vendor-specific extension points. So I think it does need a little bit of tightening up as part of Java EE7. But the API is pretty straightforward. You just give it a contextual proxy implementation, and it gives you a map of string versus string. So how do you create a contextual proxy? Well, you give it an instance of an object of where you want to capture the context, and you say what interfaces does it implement, or just a single interface or multiple interfaces that object could be implementing, and the context is captured because eventually it's going to give you a contextual proxy object. So that object is where the context is captured for you. Similarly, you can specify a bunch of execution properties with a single interface or multiple interfaces. So eventually what you get is a contextual proxy which has all the context for that implementation of the class that you passed in the instance as a method parameter here. So for example, in this sample, what I'm doing here is I am creating a context service, and again, there is a default context service that is available. So I'm just injecting a context service. From the context, I'm creating a contextual proxy. I'm passing it my implementation and the interface that is implementing. So what I'm going to get back is a proxy, which is of the type my app interface. Later, I might say proxy.do something. Maybe in a different method, I might do something, but it's going to run in the same context at the time proxy was created. So I think a slightly more elaborate example. Let's take a look at my message processor here. In an application, I might have a message processor interface. I will have an implementation of it. And then here I'm saying inject the context service in a business method. When I'm running, let's say this is in an EJB. In an EJB, when I call this business method, it's running in a class loading, security context, and all those things. Here, when I say context.create contextual proxy, I get the message processor here. I might even put it in a store, like a map. Okay? And later on, when I can say from the store, get the message processor, I could actually run the method on it. So that's the whole idea of storing the context at one place and using it at a different place. So in this case, the types of container context to be propagated, not in all the 4 objects we talked about it: class loading, Jindy, and security identity. What are configurable are via the properties, for example, and then they are extensible. For now, these are only 4 types of context we talk about: class loading, Jindy, security, and transaction. But the extensibility is really left for vendor-specific extensions, and I haven't really seen much use of that yet. And this concept of context propagation is available in all 4 objects. Okay. Let's take a look at it once again, where exactly the context is captured. So in terms of manage executor service or schedule executor service is captured at the time of task submission. In terms of manage thread factory is captured at the time of the thread factory creation itself. And in terms of contextual proxy is captured at when the contextual proxy object is created itself. Okay, so it's very important to understand where, like in this case, as soon as I inject manage thread factory, the context is captured. In manage executor service and manage schedule executor service, as soon as a task is submitted, that's when the context is captured. And in this case, once again, when I say create contextual proxy, not at the time of injection of context proxy, when I submit that, when I create the contextual proxy, that's when the object or the context is captured. The context, of course, is propagated to the thread before the task execution and during invocation of the contextual proxy object methods. And then after the method returns, the context of the called method automatically resumes. Now, as I said earlier, the transaction context is explicitly not propagated. However, what you can do, you can actually have a user transaction that is available to you. In a Java EE environment, you should be able to inject a user transaction. Or if you're running in a Java SE application, then there is an ability to generally look up a user transaction object. So you can do that too. Now, one of the things that I want to highlight here is the contextual proxy objects can run on the same transaction context of the invoking thread. And how that's possible is via the usage of the configuration properties. So remember, in the contextual proxy, we have this map of string versus string. In that, you can specify the manage task.transaction property. So using that property, depending upon whether it's manage task suspend, which is the default, that means you suspend the parent transaction. Now, if you want to run a new transaction, you inject a new user transaction and go with that. Or you can say use transaction of execution thread, in which case you are actually running in the same thread where the thread was where the contextual proxy object was created. So in terms of contextual proxy, there is a capability to at least run in the context of the called thread. Another important part to understand, we talked about all the 4 manage objects. Important concept to understand is how do we get notifications, because now these tasks are submitted and run by the container. I want to do some monitoring, which was one of the missing pieces we talked about in the beginning of the talk. So there are lifecycle event notifications that are available to you via manage task listener. You can get notifications when the task was submitted, task was not able to start or cancel, or task about to start, completed, succeeded, or failed with exception. And this is basically a simple interface with a bunch of callback methods. So you can implement those methods and then you get notification. And what you could do is, in those method implementations, you can either send an email, generate an alert, or do whatever you need to do. And then sometimes you may want to re-attempt the task. Say, hey, the task has particular fail. Then depending upon your managed schedule executor service, you may fire up the task again. Logging is a very good example on how you could use it to log what's happening across multiple threads. Yeah, we talked about remedial actions and such as resubmit a failed task. So manage task listener, and this could be associated with manage executor service or schedule executor service. Now the notification methods by themselves are run in unspecified context. They don't run in the context of that was captured. So for example, you have a manage executor service that's going to run in the context of the call thread, but the notification itself will not run in that same context. However, you could use contextual proxy object, and that's sort of an advanced use case where for some reason you want to run that in the same context. Let's say you are running a complex banking transaction. You want the logging to happen only if the user is in the right context. So then you may use a contextual proxy object, capture it at one place, use it in the managed task listener, and then you have the same security identity that is available in the managed task listener as well. So that's sort of the complex use case I was talking about earlier. So here is my managed task listener. These are very standard, very simple methods, I think. Submitted, starting, aborted, and task done. All you need to do is you pass it a future object because that's what you get when you submit a task using managed executor service or schedule executor. and you specify the object on which is being running. So here is a simple sample. You say task with listener implements runnable and manage task. So of course you have your implementation of run method here, and here you return a manage task listener. Your manage task listener could have the implementation of those tasks done, aborted, or started, and all those implementations. Later on, what you have your runnable, you have your task listener. When you say from the manage task listener or the manage executor rather, you say I'm starting a manage task. This is a new method here. So first of all, manage executors is a utility class that is available as part of Java EE7. You start a manage task. You pass it the pointer to the task, which is a runnable, and here you are passing it the task listener as well. Okay. This is going to give you back a runnable, and to your manage executor service, you submit it that runnable, not the runnable where your task is actually running. So you take a runnable, you convert it into a managed task, and then you pass that to your executor service. Very simple API here, how you can get execution properties. There are some hints that are available in terms of execution properties. Again, I haven't seen very many usage of these properties in the real life. Talked about how manage executor is a convenience class that is available. Again, it's in JavaX Enterprise Concurrent package, and how you can create manage task and other from that. The implementation of this class is already available to you. You can test whether a current thread has been marked for shutdown. So for example, that is shutdown method that is available over there. Either you can call that on the manage thread, or you can say to the manage executor, pass it an instance of the thread and say whether the thread is shut down or not. Let's skip this. Here is my manage executor API. I can create basically my 4 different ways of manage task here, and they correspond to runnable and callable. And then they pass properties or don't pass properties. And this is a simple method that I'm saying is the current thread shut down. All right, I've got about 4 minutes. I'm going to wrap up here. Now, the best way for me to learn about concurrency is the Java EE7 samples that are available on the GitHub repo. If you guys are not familiar, actually this is the wrong URL. Let me fix the URL because you're going to capture the URL in your photographs. So let's fix it on demand here. So this is github.com/Java EE sample/Java EE7 samples. So this is the correct URL. Now this is where there are about 200 plus samples that are contributed by about 40 plus people, all around the world. We're always looking for contributions. This is where we have tried out. This is how I learned the technology. This is how everybody else is learning the technology around Java EE7. So just for concurrency, there are lots of samples. Everything I showed in the slides today is available as a code sample over there. Another way to learn about the broader Java EE7 platform is I have a video course on Voxed or Parlays, actually. So you can learn about that. That's the QR code over there. There's a Voxed booth here. Go by the Voxed booth over there. Ask them about the Java EE7 course. So today I'm talking about just the concurrency. But let's say you want to understand about WebSockets, JAX-RS, JMS, managed, or batch, any of those APIs. I got about a 4.5 hour of video course that goes all of those in detail with extensive code samples and everything else. And of course, you can download Wildfly from wildfly.org. I got about 3 minutes for any questions. All right, if there are no questions, then you can catch me around in the hallway, and I'll be here tomorrow as well. Thank you.